let us see how the incidence matrix can be utilized to have more information about the network. Okay, that we shall do now, and then we'll move on to other matrices. So this was the matrix A, then reduced matrix we already have discussed. Now let us see how the network matrix may be utilized. Already we have seen that if you are having this incidence matrix, and if you know that this is the reduced incidence matrix, then from this matrix you can easily draw the graph, because you know that there is a fourth row here, because this is the reduced incidence matrix. There is a fourth row, and that row corresponds to the reference node. So since here the column-wise summation is not 0, obviously there is a +1 entry in the fourth row. That means an element is connected, element number 1 is connected between node 1 and node 4, and direction of the element is away from node 1, okay, sorry, away from node 4 and towards node 1, like this. Similarly, node element 2 is connected between node 1 and node 2, and direction of the element is away from node 1 and towards node 2. So in this way, once we are having this incidence matrix, reduced incidence matrix, you can draw the network graph. Okay, now let us see how we can utilize this network matrix to have other information regarding the network. Now let us assume that we have the vector IE, element current vector IE. Okay, so in this particular example that we have seen, say there are 7 elements. So say, let us assume that our graph, our network is a network of say n number of elements, and current in each element is entered in this vector IE. So I is basically the I1 to In transpose of this, because this is basically a column vector. Okay. Now let us see how KCL, Kirchhoff's current law, may be written using a matrix. If we write A times IE, what does it mean? IE means column vector from I1 to In. That means element current vector, and A is the node 2 element incidence matrix. Okay. This is the reduced incidence matrix A we have rewritten here, and this to be multiplied by IE. So let us multiply and see the result. It will be minus I1 plus I2, then minus I4. Minus I1 plus I2 and minus I4. Okay, we should go back to the graph again later on to see what is the implication of this minus I1 plus I2 minus I4. Similarly, let us multiply the second row with this column matrix. Then it will be minus I2 plus I3 plus I5. Minus I2 plus I3 plus I5. Similarly, last row multiplied by this column will be this I4 minus I6 minus I7. I4 minus I6 minus I7. Okay, these are the products. So let us now match this result with the graph of the network. Now remember that this is node 2 element incidence matrix. That means here these 3 rows corresponding to 3 nodes of the network, node 1, 2, and 3. Therefore, these results also will correspond to the network nodes. Okay, this will correspond to node 1, this will correspond to node 2, and this will correspond to node 3. Okay, so go back to the graph. This was the graph. Okay, say here tree and links are shown. So what was the result? It was minus I1 plus I2 minus I4. Minus I1 plus I2 minus I4 at node 1. What does it mean? Minus I1 current entering is minus I1, say, then plus I2 current outgoing minus I4 current incoming to this node. So that means the summation of minus I1 plus I2 minus I4 means sum of all currents terminating at node 1, or sum of all currents meeting at node 1. Obviously, according to Kirchhoff's current law, this is equal to 0. So we have written this product, that means A times IE, this product, the first row is minus I1 plus I2 minus I4 equal to 0. Similarly, we have got in the second row, what we got, minus I2 plus I3 plus I5, or I5 plus I3 minus I2, that also equal to 0. Similarly, at node 3, what we got here, there are 4 elements. It should be I4 minus I5 minus I6 minus I7. Okay, so what we got, okay, that should be 4. Okay, but you see the matrix 1 2 3 5. That should be 1 2 3 4. One I have missed actually. So this will be on there are 4 entries. So that has been incorrectly written. That will be basically I4 minus I5 minus I6 minus I7. Okay, I4 minus I5 minus I6 minus I7 will be equal to 0. Here, while writing this, we have missed 1. I4, I5, that has been wrongly written 0. You see that message, this should be actually minus 1 here. This should be actually minus 1 here. That has been somehow because of while rewriting, an error has been introduced here. So it should be minus 1. So please correct this. It should be minus 1. Okay. So in the next day, I shall correct this and send you the this copy of this page I will send you. But in the meantime, you can note this. Actually, there was minus 1. So I4 minus I5 minus I6 minus I7. Okay. You see, here it is. I4 minus I5 minus I6 minus I7 equal to 0. That means sum of all currents meeting at node 3. So basically, you can see that A times IE, we have verified this for this particular graph, or we have verified this for this particular network. So basically, you see that by writing A times IE equal to 0, we are writing Kirchhoff's current law. So expressing Kirchhoff's current law using graph theory is A times IE equal to 0. Okay, is it clear? Everybody, is it clear? So there is a correction here. 4 5, this should be not 0, it is minus 1 actually, that we have missed while rewriting this. I have missed, so that's why it will be I4 minus I5 minus I6 minus I7 equal to 0. So is it clear?
Yes, sir.
Okay, then you will be actually using nodal incidence matrix. There the same error is remaining here also, so there will be another entry here that we have missed. Okay, here third row 1 2 3 4 5 6 7. Yes, it should be minus 1 again. Here there is the same mistake. It has just been transmitted from the previous step. So here should be minus 1 here. Okay. So now assume that we have utilized the nodal analysis. That means we have written the expression for A, and somehow we shall see how we can solve using nodal analysis matrix, how we can solve network using graph theory. So somehow we have solved it. And solve it means while nodal analysis technique is used, what will be the solution? Solution will be the node voltages. Am I correct? When you use nodal analysis technique, what are the variables of this nodal analysis techniques? When we use nodal analysis, what are the variables? Node voltages are the variables. Am I correct? Can you understand?
Yes, sir.
Okay, node voltages are variables. So if you solve the network using nodal analysis technique, you will have the values for node voltages. That means you will know what is the node voltage vector, say Vn. Say, let us write node voltages in the form of a vector, in the form of a column vector. So in that vector, we shall have V1, V2, and V3 for this particular example. V1, V2, V3 as the variables, because node 4 is the reference. So V1 means voltage of node 1 with respect to node 4. V2 means voltage of node 2 with respect to node 4. V3 means voltage of node 3 with respect to node 4. Okay, so that is written in Vn. Now let us write A transpose Vn. A matrix is known to us. Okay, the reduced incidence matrix A is known to us. So let us write transpose of this matrix A. Okay, transpose of this matrix A and multiply this by node voltage vector Vn. We assume that we have solved for node voltages, and those voltages are written in the node voltage vector, and the entry of those node or that node voltage vector is V1, V2, V3. Am I right? Can you understand me? So I am writing A transpose Vn, and let us see what does this product means. Okay, what does this product mean to us? Okay, so A transpose Vn. A transpose is, so this is a matrix. So this will be the first column, second column. This will be the third column. But here there is a correction 1 minus 1. That correction we shall have to remember. There is a correction minus 1 here. Okay. So now if we multiply this A transpose by Vn, it will be minus V1, then remaining as 0. So minus V1. We should see what is the meaning of minus V1. Okay. Here the next row, it will be V1 minus V2. V1 minus V2. In the next row, it will be V2. V2. In the next row, it will be V3 minus V1. Okay, V3 minus V1. In the next, it will minus 1 here. So V2 minus V3 actually, it will be V2 minus V3. That one is, I have missed this wrongly. Okay, so you please note it down, and I shall also send it. The corrected page I shall send you. Before the next class, I shall send you. So it will be minus 1 V2 minus V3. Okay, I shall see what is the meaning of V2 minus V3. Then here it will be minus V3. Here it will be minus V3. Okay, so these are the voltages where V1, V2, V3. These are the node voltages. These voltages we have obtained. So another miss is here. V1, V2, V3 have written. Actually, it should be VE4, VE5, VE6, VE7. Again, while writing, I have missed to write E. So that also I shall send you as correction. Okay, but while we are making this discussion, remember that this is actually VE4, VE5, VE6, VE7. So now let us see how this is VE1, how this is VE2. VE1 means voltage across node 1. Voltage across element 1. V2 means voltage across element 2 expressed in terms of node voltages. Okay. So first of all, we shall have to go back to that drawing again. I have not drawn it here. It would have been better had I drawn it here, so I could have shown you the comparison directly here. Okay. So you see, first element is minus V1. Again, you note it here that it is A transpose. A is a matrix between node 2 element. Okay, so A transpose mode. This is a matrix between elements to node. Okay, elements here, node here. So this row correspond to element 1. This row correspond to element 2. This one element 3, element 4, element 5, element 6, element 7. So in the product also, it will be corresponding to element 1. So what is the voltage corresponding to element 1? That we have to match a voltage corresponding to element 2, element 3 like this. So let us go back to the drawing. Okay. Say this one. This one. You see that what is the voltage of element 1? This is element 1. Obviously it will be, if this is the direction, this is at higher potential, this is at lower potential, because this is the direction of current as I have shown. So obviously this is at higher potential, this is at lower potential. So voltage across element 1 is V4 minus V1. We have worked with reduced incidence matrix. That's why fourth row is eliminated. Had we worked with the full incidence matrix, then we had got V4 minus V1 as the product. Now, since that is eliminated, we are getting minus V1 because V4 is not there in our nodal in their matrix. V4 is not there. So actually you see that element voltage across element 1 is V4 minus V1. V4 is the reference. With respect to reference, that means with respect to node 4, what is the potential of node 4? It is 0. So 0 minus V1. That's why minus V1 is the voltage across element 1. Similarly, across element 2, what is the voltage? V1 minus V2. Across element 3, what is the voltage? It is V2 minus V4. So since there is no V4 in our nodal voltage vector, we shall have simply V2 as the element 3 voltage. So let us match these three: V4 minus V1, V1 minus V2, then V2 minus V4. So these three you match here and see whether we are getting the desired result or not. Okay. So here we have got V4 minus V1. So it is minus V1 element voltage or voltage across element 1. Then we got V1 minus V2 as the voltage across element 2. Then we got V2 minus V4. But since V4 is 0, it is simply V2 is the voltage across element 3. Similarly, voltage across element 4 is V3 minus V1. Element 4 is V3 minus V1. Similarly, voltage across element 5 is element 5. So it is V2. Okay, perhaps it is V2 minus V4. Across element 6, it is V4 minus V3. V4 is 0, so it is minus V3. Voltage across element 7 is V4 minus V3. Since again V4 is 0, it is minus V. So you see that by doing this multiplication, transpose of matrix A multiplied by the node voltage vector, that we have obtained the solution of the nodal analysis technique, we can have the voltage across the network branches, or we can have the voltage across the elements of the graph. Voltage across the elements of the graph means voltage across the element of the network branches. Okay, that means you see that A matrix, therefore you can utilize to write the or to obtain the element voltage in terms of the node voltages. Okay. So A matrix we are using here to obtain element voltage V1 to V7 in terms of node voltages V1 to V3. So VE1 to VE7 to obtain V1 to obtain, so from V1, V2 and V3 obtain the element voltages VE1 to VE7. Okay. Using the incidence matrix A, practically we have used transpose of A matrix and multiplied this by node voltage vector. And what was the another application? We could write the Kirchhoff's current law using the graph theory. So A multiplied by IE, that becomes equal to 0. So we can say that this product AIE equal to 0 is nothing but the Kirchhoff's current law. So could you understand the application of A and how we can utilize A matrix, write KCL, and to find element voltage in terms of the node voltages once the node voltages are obtained as the solution of the nodal analysis technique. Could you understand up to this?
স্যার স্যার সেকেন্ড ম্যাট্রিক্সটা যেটাতে এলিমেন্টটা মানে নোড ভোল্টেজ আছে সেই ভোল্টেজে স্যার V4 টা আপনি বলছেন 0 মানে প্রত্যেকটা
ভি ভোল্টেজটা 0 আমি বলছি দেখো কি হচ্ছে তুমি what you do in nodal analysis technique, what is the method? You have to consider a reference node, তাই তো? That means in the nodal analysis technique, how many will be the variables? Node voltages are variables, and how many variables will be there? If number of nodes are equal to n, number of variables will be n minus 1, because one node has to be considered as reference, that is reference for voltage measurement. In this example, say we are considering node 4 as the reference. That means all voltages V1, V2, V3, these are the voltages measured with respect to node 4. অর্থাৎ we have taken a voltmeter. At one terminal of the voltmeter is connected at node 4, another terminal connected at node 1. So I am measuring the potential of node 1 with respect to node 4. I am measuring the potential of node 2 with respect to node 4, potential of node 3 with respect to node 4. So what will be the voltage of node 4? How to measure it? You put both the terminals of the voltmeter at node 4. Then you will get potential of node 4 with respect to node 4. So what will be the value? It will be 0. That means reference node will have 0 potential, because all voltages are measured with respect to node 4. All voltages are measured with respect to reference node. Obviously, what will be the potential of reference node with respect to reference node? That is nothing but 0. That's why it is 0 in this particular case. Am I clear?
Yes, sir. Yes.
স্যার বলছি যে কোনো একটা নোটকেই রেফারেন্স নোট হিসেবে ইউজ করা যেতে পারে।
যে কোনো নোডকে রেফারেন্স নোড হিসেবে ইউজ করা যেতে পারে। সুবিধা হবে যদি যেই নোডে সবচেয়ে বেশি এলিমেন্ট কানেক্টেড থাকে তাকে রেফারেন্স করি, তাহলে সুবিধে ম্যাক্সিমাম সুবিধে পাওয়া যাবে আর কি। বুঝতে পারছো তো?
ওকে
Otherwise, any node can be taken as reference node. Is it clear? So here we have shown the application of A matrix in writing Kirchhoff's current law, and also by using A matrix how we can express element voltage. That means voltage across the element of the graph or voltage across the element of the network in terms of the node voltages. In these pages, actually there is one miss actually I have done here. Erroneously this has become 0 in place of -1. So you please note it down. I shall send you the correction next day. Okay, here it will be -1, here it will be -1. In the product there will be some correction here, some correction here, and here also there will be corrections corresponding to this one. So it will be corresponding to 5th row. It will be V2 minus V3 will be there. So this correction I will send you later on. All right, this is clear. Next, consider how to represent network blocks, because in nodal analysis we use what are the different analysis generally we use for network solution. One is loop analysis technique, then nodal analysis technique, loop analysis technique. So nodal we have discussed using matrix say we can do. Now let us see how loop analysis can be done. How can we express network loops? Already we have formed the network loops. To form the network loops, how we have started? First, from the network graph we have identified a tree. Tree will have how many branches? Will be equal to number of nodes minus 1, so many branches. Okay, so if a network is having n number of nodes, it will have its tree will have n minus 1 number of elements, and each element of the tree is called a branch. That's why I am saying that it is the network branches, tree branches. Okay, all right. So once you draw the tree branches, then what will we do? The remaining element of the graph which are not included in the tree are now the linked links. So you connect one link at a time, you will be having a basic loop of the graph. Okay, so how many links will be there? Will be equal to now total number of elements minus number of elements in the tree, that is number of branches in the tree. So these many elements, these many loops will be formed in the network graph. Therefore, for each link we shall have only one basic loop. Now those basic loops are to be expressed in terms of some mathematical notation. For that we shall be using this matrix B, and we shall call this matrix B as the loop to element incidence matrix. Am I clear? That means description of the loop, that means which elements of the graph, okay, are forming a network loop, that will be expressed with the help of matrix B. So So loop 2 element incidence matrix, its function is to describe the network loop in terms of the element of the network. So how we shall form the network this matrix B? So element of matrix B, say it is Bij. It is loop 2 element. So row correspond to loop, columns correspond to element. So Bij, it will have as before +1, -1 or 0 as the three possible entries. So it will be +1 if jth element is incident and oriented in the same direction as the ith basic loop. An element is incident in a loop if that element is a part of the loop. That means if a network element, say J, if jth element is there in the loop I, then obviously Bij will have a non-zero entry. And entry will be +1 if direction of the jth element and the direction of the loop, they are found to be same. That's why we have written this +1 if jth element is incident to and oriented in the same direction as ith basic loop. How to find out the orientation of the basic loop? It is same as the loop, as the link forming the loop. Okay, the direction of a loop or the orientation of loop is considered to be same as the orientation or the direction of the link forming the loop. All right. So if jth element and loop I, they are having same orientation, then it will be +1. If jth element and loop I, they are having, this means if first of all jth element has to be a part of loop I, then it will have +1 or -1. And then if the orientation of the element and the orientation of loop, these are different, these are opposite, then it will be -1. So if jth element is incident to and oriented in the opposite direction as ith basic loop, then it will be -1. And it will be 0, obviously, when there is no incidence between them. When jth element is not a part of ith loop, then it will be 0. Okay. So if jth element is not incident to ith basic loop. So these are the three possible entries. Would you follow how to form the B matrix now?
একবার রিপিট করবেন এটা?
হ্যাঁ, রিপিট করব কি আমরা বলছি যে I want to find out the, or I want to form the B matrix. What is B matrix? It is showing the incidence between a loop and the element of the network. It means basically it will say which elements are forming a loop and what is the direction of the loop with respect to direction of the element. This will be expressed by B matrix. So for each element of the graph, there will be an entry in the B matrix. If therefore rows will correspond to loop, because the matrix B is an incidence matrix between the loop and the element. So rows will correspond to loop and columns will correspond to elements. And entries will be +1, -1 or 0. When it will be +1 if jth element is incident to loop I. Jth element is incident to loop I when jth elements is a part of loop I. So if their jth element is a part of loop I, we say that jth element is incident to loop I. Okay, so then it will be +1 or -1. Now when +1, it will be +1 if direction of jth element and direction of loop current I, they are same. We assume a direction of the loop current. How we assume the direction of the loop current? It is assumed to be same as the direction of the link forming the loop that we have discussed. Okay, we shall have to see what is the relative direction of the jth element and the loop current of loop I. If both are found to be same, then it will be +1. If they are opposing each other, then it will be -1. Am I clear? And obviously all elements will not be taking part in loop I. So excepting those elements which are taking part in the loop, other elements are not incident to loop I. So for all those elements, it will be equal to 0. Entry will be equal to 0. Okay. So So this is how the B matrix will be formed. So let us now form the B matrix. To help, I have redrawn the graph here. So it will be helpful because we can see the graph, the writing equation, writing the matrix will be easier. Now you see that this was our tree. Element number 2 is a branch, element 3 also is a branch, element 5 also is a branch. So these 3 elements form the tree, and we call these 3 elements to be the 3 branches of the tree. Okay, there are 1, 2, 3, 4 nodes. So tree is having 3 elements. Okay, so now remaining elements, element number 1, element number say 4, element 6, element 7, these are links. So for each link, there will be one basic loop. Okay, so number of basic loop will be as many as the number of links in the tree. Okay, so this is one link, this is the other link, this is the other link, this is the other link, 4 links. So 4 loops will be there. We have identified those 4 loops. Very small letter, so easy to identify, but even then, this is a systematic method. You see that once you have drawn the tree, once you have identified the tree, automatically links are also identified and automatically loops are also identified. Because basic loop, what is the rule we are following? The basic loops will have only one link. So this link along with this tree branch forming the first loop. This link along with this tree branch is the second loop. Similarly, this link along with these 2 tree branch will fall in the third loop. Again, this link along with these 2 tree branch with the fourth loop. So once the links are identified, automatically the loops are also identified. They are defined, completely defined. There is no confusion. You need not make any extra effort to identify a loop. Okay. Also, direction of loop current is also pre-specified. How? It is specified by the direction of the link forming the loop. So this link has formed this loop. Okay, so direction, you see the loop current is assumed to be in the same direction as the direction of the link. This is the direction of the link, and this is the direction of the loop current. This is the direction of the link, so this is the direction of the loop current. This is the direction of this link, so this is the direction of the loop current. Again, this is the direction of the link, so this is the direction of the loop current. Okay, directions are specified, loops are identified. Now you form the B matrix, matrix between loops and element. Consider element 1. Element 1, it is in loop 1. It is a link, so obviously a link cannot take part in more than one loop because we are forming a basic loop. So a link will take part in one loop only. So it is taking part in loop 1. So entry will be +1 because why +1? You see that loop has formed this link has formed this loop, and direction of the loop is identified by the direction of the link. So obviously it will be +1, and all other entries will be 0 because link element 1 is not taking part in other loops. Element number 2, it is a tree branch. It may take part in more than one loops, and here it has taken part in 2 loops. It is a part of loop 1. It is a part of loop 2. In loop 1, you see that direction of the loop current and direction of this element current, element number 2 current, they are same. So it will be +1 in loop 1. This is the direction of the current through element 2. This is also the direction of the current through loop 2. So this is also same. So +1 here, +1 here. In A matrix, one entry is 1, another entry is -1. But here in B matrix, that thing will not happen. That thing may not happen rather. Okay. If both of them may be +1, both may be -1, then a loop may take part in more than 2 loops, 3 loops, 4 loops, depending upon the type of the construction of the network. Okay. Then element 3 is again a tree branch, so it may take part in more than 1 loops. So it is taking part in loop 1, loop 3, and also in loop 4. In loop 1, direction is same. In loop 3, direction is same. In loop 7 also direction is same. That means in first, third and fourth, all the rows, the entry will be +1. First, third, fourth, entry is +1. Okay. Similarly, element 4. Element 4 is a link. So it will take part in one loop. It is taking part in loop 2 because it is from loop 2. And direction will be same. So fourth element, loop 2 was +1. Fifth element, fifth element, this one. It is taking part in 2 loops because it's a tree branch. It is taking part in 3 loops. In loop 2, it is +1. In loop 3, it is -1. In loop 4, it is -1. So 2 + 1, 3 - 1, 4 - 1. Then element 6 will take part in loop 3, +1 there. Element 7 will take part in loop 4, +1 there. So this is the matrix B representing the or describing the elements forming the loop, or we can say that this matrix is nothing but the loop 2 element incidence matrix. What is the incidence between loops and the elements, and how is the incidence, whether they are opposing or assisting the loop, like that. So this matrix, therefore, whether you see whether it is clear to you or not. Bolo. The construction of the B matrix clear to you? Try to understand, try to match.
স্যার
হ্যাঁ,
লুপ 3 আর লুপ 4 টাকে একসাথে কম্বাইন করা হয়েছে?
না কম্বাইন কেন করা হবে? লুপ 3 হচ্ছে কি, আমরা কি বললাম যে a link will
স্যার ওই 4 3 7 4 3 আর 7 এই তিনটে নোট দিয়ে তো একটা লুপ হতে পারে, মানে 3 টা একটা ওই 4 আর 3 এর যে
না বেসিক্যালি যেটা হচ্ছে যে we are forming the basic loop. Basic loop means in a basic loop there will be only one link. তার একটা মাত্র যদি লিংক থাকে, বাকিগুলো একটা এলিমেন্ট দিয়ে তো একটা লুপ হবে না, একের বেশি এলিমেন্ট লাগবে। বাকি এলিমেন্ট কি হবে? বাকি এক বা একের বেশি যাই এলিমেন্ট থাকুক সেগুলি হবে ট্রি ব্রাঞ্চ। সো
আচ্ছা স্যার বুঝেছি।
ঠিক আছে, তো লিংক এলিমেন্ট নাম্বার 6, it is forming, as you are connecting element number 6 with the tree, then you are finding this closed path. In this path there are other closed paths, but we shall identify this closed path and we shall say this is the basic loop. Why? Because in this loop you see that this is a tree branch, this is the tree branch, and only this one is a link. So a loop where there is only one link is a basic loop. That's why we are identifying this loop as a basic loop. Similarly, this link, then forming this basic loop, it can form other loops also, but that loop is not basic loop. Say elements 6 7 together is a loop, but that is not a basic loop because 6 is a link, 7 also is a link. I can form other loops also. 7 4 1 obviously can form another loop, but again there are 3 links. That those 3 links cannot form the basic loop because all are links. So in the basic loop there will be only one link and remaining will be T branches. Okay, that's why in loop 3 and 4 you see that this element 3 and 5 they are common. In loop 3 there is this link. In loop 4 a link number 7, element number 7 is coming, okay, forming the loop. 7 5 and 3 forming the loop. Okay, you match it. Can you identify anybody? Everybody, could you understand how to form the basic loop, how to form this matrix B matrix, loop to element incidence matrix? Is it clear to or not? Bolo.
Yes, sir.
Okay, everybody clear? No question. If no question, then I assume that you have understood. Now let us see how this B matrix may be utilized. Okay, a matrix has been utilized to write KCL, Kirchhoff's current law, and also to express element voltage in terms of node voltage. Now, B matrix, obviously, this is the loop incidence matrix expressing the loops in the graph, okay, or expressing the loops in the network. So let us utilize matrix B in expressing the or in solving the network equation using loop analysis technique. So let us see how this B matrix we can utilize to express some property of the network. So let us write KVL, whether KVL may be written. If we write B multiplied by VE, VE means element voltage vector. Say V is the element voltage vector. Previously, we have shown you the element current vector for this particular graph. It was I1 to I7, 7 elements, so 7 current. Here also 7 elements, 7 element voltage. Element voltage means voltage across the element. Okay, so if you element voltage vector BE, it will have 7 voltages VE1, V2, V3, V4, V5, V6, V7. So if you multiply B matrix by element voltage vector, then what we get? I have written it is to be 0. Let us see whether it is 0 or not. So this is the element voltage vector B. You multiply it by the, sorry, this is the B matrix, multiply it by the element voltage vector. What you get? You get V1 plus V2 plus V2. So I think it has been reproduced correctly. 1, then all 0, 1, 1, 0, 0, 1, 0, 1, 1. Here 0, 1, 0, 0, 0, 1, minus 1, minus 1, then 0, 0, 1, 0, and 0, 0, 1. Okay, this is all right. Multiply this by the element voltage vector and multiply these two. So V1 plus VE1 plus V2 plus V3. V1 plus V2, V3. We shall see what is the meaning of this. Then V2 plus V4 plus V5. Okay. Then V3 minus V5 plus V6. Then V3 minus V5 plus V7. So these are the 4 multiplications product in the at 4 rows. Okay. This B matrix correspond to loop 2 element incidence matrix. So these rows correspond to loops, columns correspond to elements. So in the product, obviously, the results will correspond to loops. So what is V1 plus V2 plus V3 in loop 1? We shall have to see. What is V2 plus V4 plus V5 in loop 2? V3 minus V5 plus V6. What is it in loop 3? And V3 minus V5 plus V7 in loop 4. Okay, let us go back to the network graph where we have shown the identified the loops and shown the formation of the loops also. So let us observe loop 1, V1, V2, V3 all added. V1 plus V2 plus V3. So this is nothing but the sum of all voltage drop across the or around the loop 1. Okay. What is the result? What is should be the result? V1 plus V2, V3. What should be the result? 0. 0. Why 0? Because this is the sum of all voltages around the loop is 0 according to Kirchhoff's law. Okay, so this is equal to 0. Similarly, this is V2 plus V4, V5 in loop 2. This is loop 2. So in loop 2, V2 plus V5 plus V4. Again, it is the sum of all voltages in loop 2, and that also should be equal to 0. Then in loop 3, V3 minus V5 plus V6. VE3, V3 plus V6 minus V5. Okay, V3 minus V5 plus V6. Again, sum of voltages around loop 3 also will be equal to 0. And in loop 4, it is V3, then plus V7 minus V5. V3 plus V7 minus V5. So that also equal to 0. That means you see that if you multiply B by VE, the product will give us the expression for the Kirchhoff's voltage law. That is sum of voltages around the loop, and that should be equal to 0. So if I write B times V equal to 0, that basically represents, or this basically expresses, the Kirchhoff's voltage law. Am I clear? So Kirchhoff's voltage law you can write, or you can express using the network graph using loop 2 element incidence matrix B. Okay, you can write B times B equal to 0 to write the Kirchhoff's voltage law. Is it clear? Okay, any question here? Anybody? বলো, কারো কোনো ডাউট আছে, কারো কোনো কোশ্চেন আছে? Anybody having any question? Is it clear? Everyone? কারো কোনো question আছে, doubt? If there is no question, then let us see how B matrix can be utilized further. Okay, so this is KVL we have written. Now B matrix, how we can use it? Say, when you write or when you perform network analysis using the loop frame of reference, that means when loop analysis technique is used, what are the variables in loop analysis technique? What are the variables? In loop analysis, what are the variables? Bolo. Somebody
So
should.
the currents.
Loop currents. And means loop currents. That means we assume that a certain current is circulating in the loop. That is our assumption. That is the loop current. Loop current means we assume a current circulating in the inside the loop. Okay, that's why we express the current. Okay. So while we solve the network equations using the loop current or loop analysis technique, then we obtain the loop currents as the variables. Say those loop currents are actually written in a column vector, that is the loop current vector. Okay, that is a loop current vector. Say I loop. I have written that currents in a loop in a vector. So that vector is I loop. Okay, all right. Now let us pre-multiply this I loop. That means we have solved the network equation using loop analysis techniques. So we have obtained the expression, or we have obtained the values of I loop. That means all the loop currents, 3 loop currents we have obtained, and all these 4 loop currents of this 4 loop currents, and those 4 loop currents we have entered in this vector of loop currents. Okay, so this loop current vector is now being pre-multiplied by transpose of matrix B, transpose of B matrix. Okay, so let us see what we get if I pre-multiply this by transpose of B. What we get? Now, first of all, therefore, you write B transpose. This is B transpose. Means this way that you are getting the transpose. This was the matrix B, so transpose will be 1 1 1 4 0, 1 1 1, then 4 0. Then it is 0 1 0 0 1 1 0 0. Sorry, 0 1 0 1 1 0 0. Then here 0 0 1 0 minus 1 minus 1 0. So 0 0 1 0 minus 1 minus 1 0. What else? 0 0 1 0 minus 1 1 0. Okay, 0 0 1 0 minus 1 1 0. And in the fourth column it will be 1 0 0 0 1 0 minus 1 0 1. So 0 0 1 0 minus 1 0 1. So this is the transpose of matrix B. You multiply this by I loop. Now if you multiply, this is now the transpose of matrix B, means now we have the elements here, we have the loops here. There are 7 elements, so there will be 7 rows, and 4 loops, there will be 4 columns. So in the result, obviously there will be 7 rows, and these 7 rows will correspond to the 7 elements of the graph. Okay, since there are 7 elements, this matrix transpose of matrix B, this is element to loop incidence matrix. Previously it was loop to element incidence matrix. transpose makes it the element to loop incidence matrix. So elements are in the loop in the rows. So while we multiply this by the loop current vector, then in the result there will be 7 entries corresponding to 7 elements of the graph. Now, what we obtain here as the product? IL1 means loop current 1, loop current 2, loop current 3, loop current 4. So IL1, then IL1 plus IL2, then IL1 plus IL3 plus IL4. Okay, then IL2, then IL2 minus IL3 minus IL4. Okay, then IL3, then IL4. Okay, so if you multiply, these are the products. Now you identify these products. What are these products actually in the network elements, or we have shown the loops. So match this with this one. Now see the element. Basically, there are seven products. Okay, here. So 1, 2, 3, 4, 5, 6, 7. So this obviously is corresponding to element 1. What is the current in element 1? Because this is current, it may be the current in element 1. You see, what is the current in element 1? Current in element 1 is nothing but the current of the loop 1. Okay, therefore it is current in loop 1. Current in element 1 is the loop current 1. What is the current in element 2? It is loop current 1 plus loop current 2. It is, you see that loop current 1 plus loop current 2 is the element current 1. What is the current in element 3? It is loop current 1 plus loop current 3 plus loop current 4. So 1, 3 and 4 summation is the element current 1. What is element current 4? Element current 4 is nothing but the loop current 2. Only one loop here. Okay, loop current 2 is element current 4. So what is the current in element 5? Current in element 5 means here this current. It is a loop current 2 minus loop current 3 minus loop current 4. Okay, this is loop current 2 minus loop current 3 minus loop current 4. What is the current in element 6? Is nothing but the loop current 3. Current in element 7 is nothing but loop current 4. So same as the result. So you see that by multiplying transpose of B matrix with I loop, we obtain the element current. Okay, that means once you solve the loop current, solve for the loop current using loop analysis technique, you can obtain the element current by pre-multiplying the loop current vector by the transpose of the B matrix, transpose of the element to, sorry, loop to element incidence matrix. Okay, that is shown here. Okay, this is how you can actually utilize the matrix B to obtain the loop analysis, to actually to obtain the solution of the network using loop analysis technique, and you can write the Kirchhoff's voltage law using this matrix B. Not only that, after solving the loop for the loop current, then you can find the element current in terms of the loop current using the transpose of the matrix. Okay, this is what we have shown here. Now you tell me whether you could understand this or not. Would you understand this? Would you understand? Anybody, any question or any doubt? বলো, বুঝতে পেরেছো?
Yes, sir.
Okay. Then we move to C matrix. Okay, basic cut set to element incidence matrix. So you see that this A matrix, B matrix, and now the in C matrix. What we are actually doing, we are expressing the composition of the network in A, we are expressing the composition of the loops in matrix B, and we shall be expressing the composition of the cut set in matrix C. Okay, so basic cut set incidence matrix we shall form. Okay, so how we shall form is, so this is the basic cut set. So that means cut set means minimum set of elements we have discussed in the next class, in the earlier class. It is the basic cut set mean minimum set of elements removing which will divide the graph into two connected subgraph, and in the basic cut sets there will be only one tree branch, remaining will be links. The basic cut set will have only one tree branch. Okay, so that basic cut set and element, how they are actually connected, that is expressed. And as before, like A and B matrices, in C matrix also entry will be +1, -1 or 0. It is +1. Now you see that rows correspond to cut set, basic cut set, and columns correspond to the elements. Okay, so Cij is +1 if jth element is incident to and oriented in the same direction as ith basic cut set. That means if jth element is a part of the basic cut set and direction of element j and direction of the cut set they are same, then it will be +1. It will be -1 if jth element is incident to and oriented in the opposite direction as the ith basic cut set. That means if jth element is a part of the cut set and direction of jth element and direction of the cut set are opposite, then it will be -1. And it will be 0 if jth element is not incident to the ith basic group, means jth element is not a part of the basic cut set. Then it will be 0. Okay. So let us now see how we can form the matrix, and then we shall see its utilization. Okay. Now this is the tree we have formed first, and these are the link elements. These are the links. Dotted lines are links. Then we can identify. We have identified the cut set already. This is the cut set 1. That means these three. I have drawn a line. This line is cutting these three elements, and this is forming basic cut set 1. In this basic cut set, this is the only branch. That's why it is the basic cut set. Similarly, we have identified this as the second cut set. Here we have drawn an arc like this. Then element, this element, this element, this element, and this element. All these four elements are being cut by this arc. And if you remove all these four elements, then in one part there will be node 4. Other part you will have the remaining elements 2, 5, 4 together. So this is one subgraph. Node 4 is forming another subgraph. So removing these four elements is dividing this connected graph into two connected subgraphs. That's why these four elements together is forming a basic cut set. And this is a basic cut set because in these four elements, only element 3 is a tree branch. That's why it is a basic cut set. Okay. Similarly, we have identified another basic cut set, that is combination of element 4, 5, 6, and 7. Because if you remove all these elements together from this graph, then in one part you will have node 3 forming a subgraph. In the other part you will have element 2, element 3, and element 1 as the connected subgraph. So these are the three basic cut sets. Okay. Now in matrix C, we shall express the composition of this cut set along with their relative orientation with respect to the direction of the basic cut set. So element 1, this is the matrix between cut set and element. So rows correspond to cut set or basic cut set, element correspond to element. Now you see that element 1 is in cut set 1. Okay, element 1 is in cut set 1, element 1 is in cut set 2. Okay, just 1 minute. হ্যালো, আচ্ছা ঠিক আছে, আমি ক্লাসটা শেষ করে তোমাদের লিঙ্ক পাঠাবো। ঠিক আছে, হ্যাঁ। So in this matrix, you see that, sorry, in this basic element 1, sorry, element 1 is in car set 1 and also a part of car set 2. And what is the orientation? See, this is the orientation of the car set 1. This is shown here. And orientation of car set 2 is like this. Now, direction of element 1 is opposing the direction of car set 1. It is also opposing the direction of car set 2. So, in car set 1, the entry corresponding to element 1 is -1. In car set 2, the orientation of the element is again -1. Okay, is it clear? So element 1 is in car set 1, element 1 is also in car set 2. In element 1, direction is opposing the car set, and in car set 2 also it is opposing the car set. That's why -1, -n in both the places. Similarly, element number 2. Element number 2 is a tree branch. A tree branch may be present in one car set only, and it is forming basically the car set number 1, and it is deciding the direction of the car set 1 also. That's why it will be +1 and 0 in all other places. Element number 3 again is a tree branch, so it will actually it is forming a car set. This is actually forming the car set number 2. So direction of element number 3 and direction of car set 2 will be same. Element number 3, so it is a +1. So element number 4. Element number 4 is present in car set 1 and also in car set 3. In car set 1, the direction is opposing the, sorry, element 4, direction of element 4 is opposing the direction of car set 1. And direction of element 4 is again opposing the direction of car set 3. Okay, so -1, -1. It is not present in car set 2, so 0. Element number 5 is again a tree branch, will be present in one car set. It is present in car set number 3. It has decided the direction of car set 3, so it will be +1. Element number 6. Element number 6 is present in two car set, 1, 2, in car set 2 and car set 3. Direction of element 6 and car set 2 opposing. Direction of element 6 and car set 3, they are same. So -1 and +1. Element 7 present in two car set. Direction of element 7 is opposing the direction of car set 2. It is in the same direction as car set 3, so it is -1. So this is how the matrix C is formed, representing the incidence between the basic car set and the element of the graph. Is it clear or not? Bolo. Any doubt here? Any doubt? Anybody? Could everybody understand the formation of the car set matrix, basic car set to element, this incidence matrix C? Could every one of you understand this? সবাই বুঝতে পেরেছো? If anybody is having any doubt, please ask a question. Please say where you could not understand. Okay? Follow. Is it clear?
Yes, sir.
All right. Now you see that again this car set matrix, we can utilize this in different ways. First of all, we can write Kirchhoff's current law using the car set matrix. Okay, and in this very simple example, it is very easy to show that car set matrix, basic car set incidence matrix can be utilized to write the Kirchhoff's current law. Let us multiply C, this cut set matrix, by the element voltage vector IE. Okay, C is multiplied by element voltage vector IE. So rewrite this C matrix: -1, -1, 0, 1, 0, 0, 0, 1, 0, -1, 0, -1. Okay, then 0, 0, 1. So 0, -1, 1, and 0, -1, 1. So it has been copied here without any fault. So this is to be multiplied by the element current vector. There will be 7 elements. So I1 to I7 I have written. Now you multiply. What you get? You are getting -1 I1 plus I2 minus I3, minus I1 plus I2, then minus I3. Notice not I4. It is basically I3. No, sorry, it is I4. -1 plus I2 plus I0, so minus I4. So minus I1 plus I2 minus I4. Then here minus I1 plus I3 minus I6 minus I7. Okay. Then 1, 2, 3, 4 minus I4 plus I5 plus I6 plus I7. This is what we have written. So C is a matrix of basic cut set and element. This incidence is shown here. So cut sets here and elements here. So in the product, the result should correspond to the cut set. So let us see what is in cut set 1, the summation of this current, minus I1 plus I2 plus I4. In cut set 1, you see that this is nothing but the summation of this current, and this current. And then summation of the currents in the elements of the cut set. Okay, minus I1. Why it is minus I1? Because this current I1 is opposing the cut set current, cut set direction. That's why minus I1 plus I2, cut set direction and element direction same, minus I4, element direction and cut set direction opposite. That's why minus. So sum of all elements of the cut set, and if this, what is the summation of this current? All these branches are connected at this node 1, means summation of current is bound to be 0. So this is 0. Then cut set 4 currents here: I1, I3, I6, I7. Currents in element 1, element 3, element 6, and element 7. So minus I1. Why minus? Because you see that direction of the cut set, element 1 current is opposing. That's why minus I1. Then plus I3, element current, element direction, and cut set direction, they are same. So plus I3. Minus I6, because element and cut set are having opposite direction. Minus I6, then minus I7. Again, summation is sum of all currents meeting at this node. Okay. So if outgoing current is positive, I1 minus I3 minus I6 minus I7 means sum of all currents at this node. That obviously is equal to 0. Similarly, sum of currents of cut set 3. So here it is minus I4 plus I5 plus I6 plus I7. So minus I4 opposing the direction of the cut set, minus I4 plus I5 plus I6 plus I7, sum of all currents at this node. So obviously summation is 0. So you see that by writing this product C times IE, we are getting summation of currents meeting at these 3 nodes. Obviously summation of current at a node is 0. That represents Kirchhoff's current law. So utilizing C matrix, therefore you see that we can write Kirchhoff's current law. So this is another way of expressing the KCL, Kirchhoff's current law, that we have done using A matrix. Now we have done it using the C matrix. Okay, is it clear? Clear to all of you? Any question? So later on we shall show that if we write a somewhat larger network, then you see that in that case sum of cut set current directly will not be equal to the current at the node, meeting at the node. Those cases we shall show later on. We shall show later on those cases. There also we can show that summation is 0. Okay, that cases require a somewhat larger network, larger graph. I should show it if possible in the next class. I should show. Okay, is it clear? For this one, it is very, very obvious because this summation of this element current is nothing but the current at the zero at the node. So obviously you can say that C times I represents the Kirchhoff's current law. Okay, is it clear? Bolo, any question?
স্যার এখানে কি নোড 2টা রেফারেন্স?
না না, নোট টু রেফারেন্স নয়। আমরা কি করছি, আমরা যেহেতু তিনটে কাস্ট সেট পেয়েছি, তো সেই কাস্ট সেটের কারেন্ট গুলোর সামেশন। এবার নোট 2 কে অ্যারাউন্ড করে কোনো কাস্ট সেট নেই। কাস্ট সেট কোনটা আছে? নোড 1 কে লিংক করে কাস্ট সেট রয়েছে, নোড 4 কে রয়েছে, নোড 3 কে রয়েছে। তার ফলে এগুলো সাম অফ কাস্ট সেট, সাম অফ দিস নোড কারেন্ট এসে গেছে। ওকে, এবার এখানে যেহেতু কাস্ট সেট গুলো এমন ভাবে ফর্ম করেনি যে নোড 2টা লিঙ্কড হয়ে যাচ্ছে, তার ফলে নোড 2টা এখানে অ্যাবসেন্ট রয়েছে। কিন্তু আমাদের উদ্দেশ্য হচ্ছে দেখানো যে this caste set matrix can be utilized to write the KCL equation. KCL equation means sum of currents at the node. এটা দেখাতে পারলেই হলো। আমরা দেখাতে পারলাম যে এই এলিমেন্টের কারেন্টের সামেশন 0 হবে। নোডটা এখানে খুব গুরুত্বপূর্ণ কিছু। নোডটা ঘটনাচক্রে আমাদের দেখাতে সুবিধা হয়েছে। আমি বললাম যে নেক্সট আমরা এমন এক্সাম্পল নেব এখানে সরাসরি কোনো একটা নোডকে সরাসরি রেফার করবে না, তখন ব্যাপারটা আরেকটু ইন্টারেস্টিং মনে হবে আর কি। এখানে খুব ফার্স্ট দেখাচ্ছি বলে আমি একটা ছোট নেটওয়ার্ক নিয়ে দেখালাম, হ্যাঁ এরপরে আমি একটা বড় নেটওয়ার্ক নিয়ে দেখাবো, তখন ব্যাপারটা দেখবে যে সরাসরি in certain node is not being actually directly connected with the writing of this KCL equation. ওকে, সেটা আমরা আরেকটু পরে নেক্সট ক্লাসে আজকে দেখাচ্ছি না, এবং সেটাই নোটেও নেই। আমি পরে দেখাবো বলে একটু লার্জার নেটওয়ার্ক নিয়ে দেখাবো বলে সেটা পরের দিনের জন্য আমি রেখে দিলাম, সেটা আমি নেক্সট ক্লাসে দেখাবো। ওকে, সো নোড ইজ অ্যাপিয়ারিং হিয়ার, কি বলবো, অ্যাজ এ কনসিকুয়েন্স। ওকে, ইনসিডেন্টালি এটা আসছে, কিন্তু আমরা লিখতে চাইছি সাম অফ দ্য কাস্ট সেট কারেন্ট। বেসিক্যালি দ্যাট আই হ্যাভ রিটেন, সাম অফ কাস্ট সেট কারেন্ট ইজ 0। আমি যদি এখানে ঘটনাচক্রে এই নোটগুলো পাওয়া গেছে বলে আমি 0 লিখছি, কিন্তু আলটিমেটলি আমরা কি লিখলাম? আমরা লিখলাম algebraic sum of the caste set current is 0. Algebraic sum of the caste set current is 0. This algebraic sum of caste set current may not always directly indicate a certain node. এখানে এই নোডটাকে ইন্ডিকেট করছে, এই নোডটাকে ইন্ডিকেট করছে, এই নোডটাকে ইন্ডিকেট করছে, কিন্তু পরে আমরা দেখব যে it is always the cases may not be like this. Okay, one such case I shall show you in the next class. But for this particular example, is it clear that we can write C times I equal to 0? Is it clear?
Yes, sir.
Okay, then you see in another way how we can use C transistor. After এটা করার পর আজকের জন্য আমি রেখে দেব, নেক্সট ক্লাসে আবার তাহলে ডিসকাস করব। Now let us see how again we can utilize this C matrix. Actually, so far we have shown you the two way of solving network equations. একটা হচ্ছে কি writing nodal analysis or using nodal analysis and then using loop analysis. There may be a third approach using the branch frame of reference. In that case, we shall be solving the network in terms of the branch voltage, in terms of the three branch voltage. Three branch voltage সঙ্গে node voltage এর একটা তফাৎ রয়েছে। কি রয়েছে? In the three branch voltage, actually, we are not taking a certain node as reference. Okay, in the nodal analysis, we take a node as reference. While we write or while we solve the network using the three branch voltage, then a particular node is not considered as reference. Then we rather consider the potential difference between two nodes as the variable. Okay, তাহলে কি ধরছি? আমাদের ক্ষেত্রে কি রয়েছে? We have the three branches. This is the tree branch, this is the tree branch, and this is the tree branch. So variables will be actually V1 minus V2 will be a variable. This is the voltage across element 2, which is tree branch. This is tree branch corresponding to caste set 2. So what will be the variable? It will be V2 minus V4. That means tree branch will be, tree branch voltage is this voltage drop across the tree branch. Basically it is node voltage 2 minus node voltage 4. Similarly, tree branch 3, third set এর সঙ্গে যেটা linked, that will be V2 minus V3. Okay, so you see that when you consider this voltage as the variable, this voltage as the variable, this voltage as the variable, then we are considering a pair of nodes. Okay, node pair potential সেটার নাম একটা বলা হয়। Three branch voltage গুলোকে আমরা যখন ভেরিয়েবল ধরি, then these variables are sometimes referred to as the node pair potentials. Potentials of node pair 1 and 2, potentials of node pair 2 and 3, potentials of node pair 2 and 4. Okay, so these will be considered as variable. তাহলে আমি যখন কারসেট ম্যাট্রিক্স ইউজ করব, then we shall be solving the network using the in terms of tree branch voltages. Say those tree branch voltages have been obtained as the solution of the equation, network equation. তাহলে now let us see what happens if we pre-multiply this tree branch voltage vector by transpose of the C matrix. So tree branch voltages means vector of voltages. Okay, three voltages. এখানে আমাদের বেলায় কি হবে? There will be three voltages VE2, VE3 and VE5 will be the variables. VE2 means আমাদের ক্ষেত্রে tree branch 1 voltage, V3 means tree branch 2 voltage, V5 means tree branch 3 voltage. Okay, so these are the variables. Then these variables are being multiplied, pre-multiplied by transpose of C. So this is the transpose of C. C was the matrix between cut-set and element. So if we take the transpose, it will be element to cut-set. Element here, cut-set here. Elements corresponding to the rows, cut-set corresponding to the columns. So if you multiply, obviously in the result, there will be 7 elements corresponding to 7 elements of the graph. This voltage vector has 7 elements corresponding to 7 elements of the graph. So what are the products? It is minus VT2 minus VT3 means minus VE2 minus VE3. Then it will be VE2. Then it will be VE3. Then V2 minus V2 minus V5. Then it will be V5. It will be VE3 minus V3 plus V5 minus V3 plus V5. Okay, these are the products, 7 products. Now let us see what does this mean. Minus V2 minus V3. Element 1 voltage আমরা কিভাবে আইডেন্টিফাই করতে, minus element voltage 2 minus element voltage 3. Let us go back to the graph. Okay, go back to the graph. You see that minus V2, okay, minus V2 minus V3, minus V2 minus V3. You see that what is the meaning of minus V2 minus V3? এই দুটোর মধ্যে তার মানেটা কি? মানেটা আমরা কিভাবে বার করতে পারি? I can now consider this loop. So V2 plus V3 plus VE1 equal to 0. তাহলে আমি বলতে পারি যে minus V2 minus V3 means VE1, because VE1 plus V2 plus V3 is equal to 0 in this loop. আমি বলতে পারি যে VE1 equal to minus V2 minus V3. So this is nothing but VE1, element voltage 1. Similarly, this is equal to VE2. Certainly it is the element voltage 2. This is directly equal to VE3. Then minus V2 minus V5. Minus VE2 minus V5 minus V2 minus V5. আমি এখানে কি করতে পারি? V2 plus V5 plus V4 equal to 0. তাহলে আমি বলতে পারি V4 means minus V2 minus V5. I can say V4 equal to minus V2 minus V5. I can write as V5. And then it is V5 directly. I can write V5. Then V5 minus V3. VE5 minus V3, VE5 and V3. So I can write V3 plus V6 minus V5 equal to 0. So what we can write? V3 plus V6 minus V5. So V5 equal to V3 minus V6. So V3 plus V6. Okay. So I want to find V6. Okay. If we take the summation, একটু পরে আমি তোমাকে ফোন করছি, হ্যাঁ। So you see V6 minus V5 plus V3 equal to 0. Okay. So what you can write? You can write V6 equal to, okay, you have written V6 minus V5. So V6 equal to V5, then minus V5 plus V3, or sorry, V6 equal to minus V5 plus minus V3 plus V5. Similarly, V5 minus V3, what does it mean? V5 minus V3. Again, that means you consider this loop once,
Sir.
and then this loop another time. Yes?
স্যার V1 V2 V3 কোনটা নেব স্যার? কোন স্পেসিফিক মানে
No,
কিছু ভেবে নিতে?
আবার বলো, কোশ্চেনটা বলো।
স্যার V1 V2 V3 টা কোনটা নেব? কোন স্পেসিফিক কিছু আছে?
না না না, কোনটাকে আমরা কি পেলাম? আমরা এখানে এই প্রোডাক্ট থেকে কি পেয়েছি? প্রোডাক্ট থেকে পেয়েছি দিস ইজ দ্য ট্রান্সপোজ অফ ম্যাট্রিক্স সি multiplied by the 3 branch voltages. Okay, 3 branch voltage ki 3 branch voltage is, this is 3 branch, first 3 branch corresponding to set 1. What is this voltage? This is VE2, element voltage 2. This is the second 3 branch. What is the voltage? Element voltage 3. This is the third 3 branch. What is the voltage? Element voltage 5. So V2, V3, V5 are the variables. V2, V3, V5 are variables. Now you multiply this transpose of symmetrics by this voltage vector and got this result. Now you identify what is the meaning of minus V2 and minus V3. How to identify the meaning? See that minus V2 minus V3. You go back here.
স্যার এটা জানি স্যার, কিভাবে আইডেন্টিফাই এটা বুঝতে পেরেছি।
আইডেন্টিফাই কি করে করবে? কারণ দিস ইজ corresponding to the elements. That means C means the matrix between cut-set and element. So if you take the transpose, it will be a matrix between element and cut-set. So here we have 1, 2, 3, 4, 5, 6, 7 elements. 1, 2, 3 cut-set. So this will corresponding to element 1. This is element 2, element 3, element 4, element 5, element 6, element 7. So let us see whether, or what is the meaning of this. We have seen that this basically is nothing but the element 1 voltage. This is element 2 voltage. This is element 3 voltage. This may be shown to be element 4 voltage, element 5 voltage. This is combination of these two. If we go back to the network graph, there you can show this is a part of the loop. So from that loop, we can find out the element 6 voltage. Again, this is a part of the loop. So once we can form 3, 5, and 6 as the loop, and then we can form 3, 5, and 7 as the loop. So in this case, since this is corresponding to element 6, we shall consider element 6. This corresponds to element 7, we shall consider element 7. Okay. Because this is 7th row, we shall consider element 7. 6th row, we shall consider element 6. 5th row, here element 5. 4th row corresponding to element 4, like that. Is it clear?
Yes sir, yes sir.
Okay. So now you see that by writing transpose of symmetric matrix and multiplying this matrix by the 3 branch voltage, we can have the element voltages. So once the solution of the network is obtained in terms of the 3 branch voltage variables, then using the transpose of the symmetrics, you can have the element voltages by this product. That means symmetrics may be utilized in writing KCL, in solving the network using branch frame of reference, and then expressing the element voltages in terms of the 3 branch voltages. So this is how this A, B, and C matrices we can utilize to solve the network equations in writing Kirchhoff's current law and voltage law, and expressing relations between different variables of the network. Okay. Is it clear up to this much? Then we should see how these equations now may be formed to include the, or to complete the writing of the network equation, including the voltage sources, current sources, impedance, everything. Then that we shall see later on. Today we have considered how these equations may be utilized to express some variables and also to write KVL and KCL equations. Is it clear? ঠিক আছে? All right. বলো, any question এখানে up to this? Is there any question?
স্যার একটা কোশ্চেন আছে।
বলো।
স্যার বলছি আমরা যে এই কাট সেট ম্যাট্রিক্সটা ট্রান্সপোজ নিয়ে ভোল্টেজ ম্যাট্রিক্সের সঙ্গে মাল্টিপ্লাই করে ব্রাঞ্চ ভোল্টেজ গুলো পেয়ে যাচ্ছি, মানে এটা কি কোনো ল নাকি এমনি ট্রান্সপোজ নিয়ে নিচ্ছি?
না না না, ট্রান্সফার করে দেখলাম, এটা কোনো ল নয়, এটা করলে পাওয়া যাচ্ছে, পাওয়া যাওয়ার একটা সম্ভাবনা ছিল, এক্সপ্লোর করে দেখা গেল যে পাওয়া যাচ্ছে, তাই তো? অলরাইট, তুমি
মানে
দেখলে
এমনি
যে এইভাবে এক্সপ্রেস করা যায়, অলরাইট, বিকজ দিস ইজ এ ম্যাট্রিক্স বিটুইন cut set and element, and if you know the tree branch voltages, then whether or how you can actually determine the element voltages in terms of tree branch voltages, that we have explored, and that has been expressed here, that has been shown here. Okay, you can see.
Yes, sir.
Any other question by anybody else? Bolo. Because unless you understand up to this thing, then proceeding to the next step will be meaningless. Okay, so you must clarify these things clearly first, then only you can proceed to the next topic, writing equations using network parameters, voltage current sources, and we shall be writing network equation to solve for loop currents, node voltages, and tree branch voltages. Okay. All right, if you go through this, study this, and then we shall again meet in the next class on Friday. Okay, on Friday. Okay, so তার আগে before I make your roll call, তোমাদের একজন হোয়াটসঅ্যাপে পাঠিয়েছিলে যে রিগার্ডিং সাম ডাউট, তাই তো? কে পাঠিয়েছিলে? তার নামটা যেন ভুলে গেলাম আমি। আগের দিন কে পাঠালে বলো? Some of you, you have actually sent this one. So you see that the impedance matrix Z. Okay, this was an error. So impedance matrix Z, whether this is correct or not, there is some confusion. So let us verify. So it is J4 3 in the first. This is self impedance of loop 1. This is loop 1 and loop 2. Already we have considered loop 1 and loop 2 in our previous. Okay, so in this case, and there is some mutual coupling also. Okay, it is all right. So one thing, if you, when you write the impedance matrix, always you try to draw the equivalent circuit first. That will help you. Okay, so don't write network equation directly from here. Rather, you do one more step to draw the equivalent circuit where in mutual coupling will be represented as controlled voltage sources. Okay, so draw one more circuit through the controlled voltage source, then you will be adding up the impedances in the loop to form the self impedance, impedances in the second loop to form the self impedance, and mutual will be common impedance with a negative sign. So there perhaps is the question, common impedance with a negative sign, সেখানে কোনো একটা প্রশ্ন ছিল, তাই তো? কে বলছিলে বলো? Have you tried by writing the mutual coupling, because there is a mutually coupled voltage is there. Here K is 0.5. What does it mean, K 0.5? কে পাঠিয়েছিলে কোশ্চেনটা? আমি তো নাম ভুলে গেলাম।
এটা স্যার এখানে যে কে বলতে এটা হচ্ছে মিউচুয়াল ইন্ডাকটেন্স। হ্যালো,
K means
Sir.
coefficient of coupling.
yes sir.
Okay, so what does that mean?
So here the mutual inductance is equal to K into root over L1 into L2.
তার মানে কত হলো? L1 is here, it is in ohm.
It will
You
be
find out, you go back, find out L1, find out L2, then K
Yes,
is
sir.
here, so you'll be finding the mutually induced EMF, mutual couple will be finding out. Then you draw the equivalent circuit, okay? You draw the
Yes.
equivalent circuit and do and see whether it is matching or still it is. Have you tried that way?
Sir, it is not matching, sir.
Not matching.
Yes.
What they have done, they have considered this plus. Regarding J, what they have considered.
Yes, sir.
But obviously
In the
minus
common,
J, so it is when we write it is this branch, it will be actually appearing as a negative impedance in the first loop. In the mutually induced EMF, it will be in Z12. That is loop impedance matrix. That means Z12. There it will be minus of 3, then plus J5. It will be minus of 3 plus J5. All right. Plus, because a minus 1 is there,
yes,
that will be it is
it's a
minus,
minus or minus J.
and then if we actually adding those mutually coupled voltage also, then we'll see whether the final form is this one is or not. If there is error, obviously that is error. They have done some error. Maybe it is a printing error, or while writing they have done some mistake. It may happen. Okay, is it clear?
স্যার সার্কিটটাই ড্র করতে গিয়ে যদি স্যার ওই DI1 DT টার্মগুলো চলে আসে তাহলে স্যার ওগুলোকে এলিমিনেট করবো কি করে?
এলিমেন্ট রেখো, লিখে আমাকে দেখাও নেক্সট দিন। ওকে, ড্র করো, but what is the source here? It is written 10 at an angle of 0. What does it mean? It means that the source is a sinusoidal source. It is a sinusoidal source. So we are dealing with phasors. So I1 is a phasor, I2 also is a phasor. Okay, that's why J4 they have written J4. Why they have written J4? So dI1 dt will not come. It is represented by ddt. Basically, when you using the phasors, ddt basically is equal to what? It becomes j omega. Ddt will be actually replaced by j omega. Okay, so you write those things and write the expression in terms of impedances. That's why it is J4 is here, because this is basically a sinusoidal source. তো এইগুলো আসলে তোমাদের তো এখানেও করানোর কথা ছিল, এগুলো তো তোমাদের ফার্স্ট ইয়ারেই করার কথা ছিল, এগুলো করানো হয়নি ফার্স্ট ইয়ারে, because otherwise why you should not actually, while actually in the second year you should not ask this question, why, what will you do if DDT comes? Okay, because when you are dealing with the sinusoidal source, when DDT comes, that means that will be replaced by j omega. And why that is being replaced by j omega? Those things are supposed to be discussed in the first year classes. যদি না হয়ে থাকে তাহলে আমি তোমাদের আবার এগুলো ডিসকাস করে দিতে পারি। তোমাদের কি এগুলো হয়নি, ডিসকাস করা হয়নি? বলো, কারণ সেটা না জানলে পরে একটু মুশকিল হবে, কারণ আমি তো ধরে নিচ্ছি যে এটা জানা আছে। If that is not known, then obviously I am jumping steps. That is not desirable. বলো। বলো, বাকিরা কেউ বলো, তোমাদেরকে এগুলো ডিসকাস করা হয়েছিল? any answer? ডিসকাস করা হয়েছে না হয়নি ফার্স্ট ইয়ার ক্লাসে? Because accordingly I will have to discuss here. If those things were not discussed, then I shall have to show. Or if those things were already discussed, then why I shall spend time here unnecessarily. Okay. So, bolo, anybody else? Okay. So now let us call your name.